Hello everyone. So this is the lab for this is the first series of the lab for the how to work with Google Cloud Composer environment and how we can use it as an environment to use the Airflow, which we use it for orchestration between different tasks and functions that we will define in a pipeline. So what I've prepared, like the whole lab and a very detailed, again, README file. And this is a lab that it's a little bit beyond basics. So what we will learn at the end of this lab is how to set up the Google Cloud Composer environment. So the Google Cloud Composer environment is just a managed Airflow service for us that Google Cloud provides for us. So we don't need to take care of anything of this, and it automatically, as long as you give the service accounts the required permissions, you can interact with different Google Cloud services such as GCS or BigQuery or compute engines and all these things. And we will learn how to write the conditional task, like what is the task, how to write the conditional task, and how to do the branching in Airflow. And we will learn how to use hooks, which is just a tool provided for us by the Airflow, Apache Airflow, to interact with external APIs and services such as Google Cloud Storage and BigQuery. And we will learn how to write data. So imagine we have a data on GCS and we want to write it to a table in BigQuery, how to do this in Airflow and in specifically in Composer environment. And we also understand the environment variables which are accessible to us in the GCP Composer environment, and we will learn also about the trigger rules in Airflow. So as you can see, this is a little bit beyond basic because there is already a basic lab. So what I wanted to do is to give a little bit of a higher level of picture about what things you can achieve by using the Composer environment of GCP. So okay, so so first of all, to follow along this lab, we need to create a project. So I already created a project, and the name of the project is Project Composer Demo. So by following any lab in this MLOps course, you should be able to do this. You create a new project, and Project Composer Demo. And then after that, what you need to do, you go to the Composer environment by looking at here and here. So as you can see, you are in the Composer environment, and probably and one thing is, after you created this Project Composer Demo, you need to also enable one API, and that's the Composer API. And how you will do it, you go to API and Services, enable API and Services when this project is chosen, is selected. And now we will wait for it to be to go. What's happening? Yes, so now we are here, and now you say enable APIs, and you need to go look for Composer API, something like that. Composer API. Yeah, Cloud Composer API. And probably this wouldn't be enabled once you create the project. You need to enable it this way. And once you enable this, now you can use the Composer environment. Now, you go to the Google Cloud Console. Then you look for the Cloud Composer here. And if you haven't created, so as you can see, I already created the Composer demo environment. But if you haven't created anything, you can just click here, create. And there is this preview, like this is the latest version, it's Airflow 2 auto scaling, but because this is a preview version, I'll went with this version, Composer to Airflow 2, and there is also auto scaling feature of it, which just balances how much load you are using through the workers for from your Composer environment. So you choose this, and then here you need to set up what's the settings. The first thing you need to do, you choose the name for it, and then once you choose the name for it, let's say Composer and Demo, and then let's name it 2. And then you choose a location for it, US East 1 or US East 2. This is closest to our location in Boston. And then image version, leave it as it is, just the version of that Airflow you want to use, like what version of the Airflow and Composer you want to use, like leave it as it is. And so by default, a service account dedicated for this environment will be created, by which also has compute and compute name in it, like this service account. This is default, and you leave it as it is. And this service account will have the permissions. We'll check what permission it has also, like later. And labor just as resilience mode standard. And this is how you choose the environment resources, like how do you want, because this is an environment provided for us. This is basically servers, workers, how many, like we will have 3 workers if you choose the small, and then if you choose medium you will have 6 workers, which like each of them they have a 2 vCPU with a 7.5 gigabyte memory and 5 gigabyte of storage. And large you will have more workers, and custom you can choose how many more. But because this is just an example, so it's a light work, you just need to go by the small. But if you want to do something for your project, which I highly recommend, that you need to like accordingly like change this like workers, like maybe go by medium, large, based on your need and preference. And network configuration, nothing changed. And now you hit the create, but I'm not doing this already. I already created a composer environment. This is all you need to do. And because it takes on average between 20 minutes to 30 minutes for this to be created, and then once you create it, everything is set to go. So this is how I created this environment. And as you can see also, let me show you in the DAGs folder. So this is how you work. You choose this, you go to here. This is like gives you a couple of information, necessary information. Like first, this is the logs that they are available for this environment. DAGs, like what are the DAGs that you will have. And environment configuration. This is the settings that you've chosen. For example, let's say you have 1 scheduler, 1 trigger, and you have 3 workers, and all this information over here. And then you also probably you have access to the service account here. As you can see, this is the service account for it. So let me just show you something real quick. So on Google Cloud here, we go to IAM and admin, and we will look for that. And as you can see, this is the service account for that environment. This is the service account default by the compute engine. And you choose this, and grant access editor. So you go to service, you go to service account. This is that service account, and you go here and you go to permissions. So by default, the GCP will give the necessary permissions, like which is like one of the permissions that, let's say you want to add here. You go here, you want to like give it a new role permission, and you go to the details, enable service account, description. So as you can see here, you need to give it like the necessary roles, but already the roles, this service account will have access to the GCS, and will have access also as a composer administrator. But let's say you want to add a role, add another role, and you say this composer administrator. Yes, composer administrator. This is full control of the composer resources. So this is already given to that default IAM, but this is how you also can give further roles to this service account related to that composer environment. So you know. So this is what I wanted to show you. So one more time, let me cancel this. So you go here to IAM, then you choose this, edit, and then you can add other roles. This is how you do it. So now let's go back to this environment, and we go to the environment. This is the environment. So how you work, once you create an environment, GCP automatically creates also a bucket for this environment. And as you can see, the name of the bucket, I haven't chosen this. It's like US is composer demo some number bucket. This is the bucket. And in the bucket, there are also a couple of objects already. There are a couple of blobs or files like DAGs, data, logs, plugins. And in this, how you tell the composer environment that I want you to run these DAGs is you upload the DAG that you want to run in this composer environment under this DAGs folder. So under this DAGs folder, this is just by default, there is an Airflow monitoring which doesn't have any task or DAG, and this is by default, and this is how you upload a file and do it. So now let's do this, but there is also a little bit of delay before we do it. So this is, you just choose upload, delay, upload files, and this is that DAG that we want to run. Let's say this is the DAG for our project, and we choose this file. This is a Python file, and we say open and wait for it, and this is uploaded. So but the thing is, there is also a little bit of delay between the synchronization of the GCS bucket related to this composer environment and that composer environment. So for example, how I can show you, let me refresh this, and so you expect, so now we want to check if the DAGs is there in this environment, like, but if you go to the DAGs, as you can see, there is still one DAG. So it takes like about 4, 5, 6, 7 or 10 minutes on average to this get synced, because also I did a little bit of research about this, and even big companies, like, they were a little bit complaining about this delay in synchronization, and it depends also on the power of your workers, how like they are strong, but because ours was small, also it takes a little bit longer. So even if I click here, refresh, there is no DAG that that GCS, as you can see, this GCS to BigQuery iris is here and should be reflected here, but it's not. So I'm gonna pause this video for now, and once this is this shows here, then we resume again this lab together. Okay, so now now the file is here, as you can see, like it's in the, let me go here. This is the composer environment, and if you go to this composer environment, if you go to this DAGs list here, that GCS to BigQuery iris DAG is uploaded here, so we can use it now. So but before running this DAG, let us go through the what this DAG is going to do in general. So this is the structure. Let me just give you a bigger picture of this DAG. So what this DAG does is that first, this DAG checks if the data, our data, which is just like iris data, and it can be the data for your project, is this data available on that bucket, different from the bucket related to the composer. This is a bucket for our data related to the project that we created. This is just imaginary situation. And let me show you here. If we go here on the bucket details, as you can see, there are two buckets. One is this bucket, which is related to that composer environment, and one is this bucket, which I created this manually myself, composer demo bucket. And let me also remove this, so you will see that. So this is from the previous runs, and there is no data. So imagine you created this bucket for your project, and there is no data to it in it. So what this DAG does, first it checks if there is any data in this bucket, and if there is no data in this bucket, then there is a condition here. It downloads the data from a link, and this is how you can also set up your project, and this is extremely also useful and beautiful. And then it will upload it to that GCS bucket, and after uploads it, it also create a BigQuery table based on that data. So you not only also store it somewhere on GCS, also you convert it into a BigQuery table. And this DAG also, if the data already exists in this bucket, it checks it, and then it just runs a dummy task, which is just doing nothing, just a placeholder for a task. And then what it does, it just reads that data into a BigQuery table. And then imagine you can do other steps, like right after this step 2. Let's say you have a step here for data pre-processing, you have a step for training model, and other tasks. So this is how you manage your whole tasks and orchestrate them using these Airflow DAGs. So now let me also show you the code for this. Now, as you can see here, we have a GCS to BigQuery iris Python function, and this is our DAG. So okay, so first there are these imports. So first you import the Airflow, the DAG module from the Airflow. Then you import like the GCS to BigQuery operator. This is the operator that changes a data to a BigQuery table. This is like a service available to us from the Airflow. And we also use a Python operator. Python operator is for running Python functions. And then you use a bash operator for running the bash commands, like a terminal. And then there is also GCS hooks, which I explained what are hooks. Hooks are just tools provided again by Airflow for interacting with external resources like Google Cloud, like AWS, like Microsoft Azure, and all these services and other services as well. And this is the dummy operator that again we import. The dummy operator I told you, this is just an like operator like Python but bash, but it does not do anything, but it's a placeholder, which in some cases it's necessary. And the next one is this branch Python operator, and then I'll explain what is this branch, and then a trigger rule, and also some Python default modules like datetime, time delta, and OS who are interacting with the operating system. So in this DAG, first of all, we have a bucket name. Here, this is the name of that bucket, that original bucket that stores the data. This is the bucket, not the bucket for the Composer environment, but the bucket for storing the original data. And the iris file name, what's the file name that you want to download? This is the file name. So we define this as two variables at the beginning of the script. Now, there are some environment variable when you work in the Composer environment in GCP available to us. One of these is project ID. So this project ID is this like the project ID, this project Composer demo, this project ID, as you can see here, you can access this in the Python script through this os.environ.get and the GCP project. This is the name of that environment variable that the GCP recognizes it. And there are multiple other environment variables that we can also access. So this is, we define the project ID, and there are also some default arguments, like what's the start date, we defined it as the beginning of the 2024, and then other like emails on failure and stuff. So, and also retry delay, we say like put some delay between each run when you run the whole DAG, and we define it as a time delta object. The time delta object is a duration. We say the duration is 5 minutes. So every 5 minutes, retry, put a delay between retrying running the DAG. And here you define a DAG instance. This is a DAG instance by using the DAG module, and you name it. The name of the DAG is GCS to BigQuery iris. And let me just so in this Composer environment, this is, as you can see, Airflow web server. This is the Airflow UI. You click this and you will see that you have a similar environment as you also run it as you can see, GCS to BigQuery iris. This is the name of the DAG, and this is the same name that you give here to the DAG, like this name. And default args, we pass it here, and description, just a description, and a schedule interval. Again, we give it a time duration, time delta days 1 this time, or you can say @ daily. Also, Airflow works by this notation, which is some other ways to give the schedule interval. Now we go and define the functions that we want to run. We want to run in this thing. So let me just open this in a different tab. So these are all functions and tasks we want to. This is the first function now we want to define here, and in this function here, this is a function check file exist, and we define this just as a *key w args. So what we are saying, because Airflow by default passes a couple of like default arguments to each task, you just let it as this and let it like be available to Airflow, so it doesn't throw any error. And so you don't need but to pass any argument to this function, at least in this example. And first we define a GCS hook instant by using the GCS hook function, which we imported on top here. And this GCS hook is a hook for interacting with Google Cloud Storage. And we say if GCS hook.exist, the name of the bucket and the name of the data file, which we define on top here, the name of the bucket and the name of the file. We say if this file exists in this bucket, then return file exists dummy, and If not, return download iris data. So this is the important part. This function here is going to be used by branch Python operator. This branch Python operator is what makes these two branches here. So it says either go this way or either go this way. And the return of this function is the task ID that you define later. So the task ID file exists dummy. This is the task ID, as you can see here in file exists dummy. This is a dummy operator which says do nothing if the file exists. But if the file does not exist in the return the task ID of this download iris data. And this download iris data, as you can see, the task, we define it below here. Download iris data, this is just the name of the variable, but this is the important part. This task ID that you define here, which is just a bash operator. We use the cur command to download the iris data from a link from the UCI repository, and this is how you might also have the data for your project. And we say store it in the temporary directory as the iris file name file on the worker server of the Composer environment. This is how we save it. And so this function that you pass to this branch Python operator should return basically two task IDs, either this task ID or the second task ID, the second task that you want to be run after this. Then we define a function to upload our dataset to the GCS. Again, because we are interacting with GCS, we define a GCS hook. We say GCS hook upload, we give the bucket name, the file name, and we say where to find that file on the local server, on the local machine, which is that Composer worker machine, which we saved it here on this folder. So we are reading it again from this folder, and we are uploading that on this bucket of our project. Then we define the task for this function. We use a Python operator because it's a Python function, and we name it upload to GCS. This task ID is upload to GCS. Python callable, we just give the name of the function without the parentheses because this is just a callable, and we also pass which DAG instance should be part of. Then we use also the placeholder for when the data exists. We don't want to do anything because the data exists, and we want to just go to the next step, which is load to BigQuery. Now we are not defining any Python function or any bash command. So we want to just convert that data that exists on the bucket to a BigQuery table, and we do it by this function, by this operator available to us by the Airflow. So we name that task, we say GCS to BigQuery. We say where this GCS to BigQuery function on what bucket they should find this data. The bucket name we pass it. What's that data? The name of the data source object can pass a list of the, like as you can see, a list of the data. It's iris file name. And destination project dataset table. This is the project ID .mlops.lab.iris dataset. So what is this? Let me go through this. So we are on this project. You go to BigQuery, and let's say you are working on your project, and this is the name of that project that you are having. You click here, and as you can see, you create here. You create a new, like you can do this, like create dataset. You create a dataset. Let's say you give it a name, multi-region, pretty simple and straightforward. All the settings you leave it as it is, and the location, like it doesn't, just leave it as multi-region. And as you can see here, you just create a dataset. You don't do anything, just a database basically. And the name of the database is this mlops_lab, just a name that you choose. And this name is important. This is where we are telling this GCS to BigQuery operator to store that table. We say go to this project ID, which we accessed it by the environment variable on top of the script. We say dot the name of that database, mlops_lab, and also automatically it creates this table for us by the name that we pass. It will create this table as the name iris_dataset. There is no such table right now. but it creates it for us. So right now there is this table in my case, so let me remove it right now. So you can see I just deleted that table, but once we run that script, it automatically creates that table. And then you also pass a schema field. This is just a custom thing that BigQuery requires from us. You tell us each column, what's the name of the column, what should be the type of the column. The type of the column are float numbers, and mode. Does it accept like null values or not? Yes, nullable, all of them. You pass it as a dictionary, a list of the dictionary, a schema of fields. This is also one parameter that this GCS to BigQuery operator requires. And write disposition, write trunket, which means that if there exists such table, rewrite it again. There are multiple options here that you can look it up on this under this operator in Airflow documentation. And the source format, what's the format of that data? CSV. Field delimiter, what's how it separates these different columns by a comma, because the CSV file. And this trigger rule, this is also important. This trigger rule is saying this trigger rule, you can also change this to so let me just find the, so this is trigger rule. Let me, if we go to we go to the documentation of the Airflow to see what are the options for us. This trigger rule. Yeah, trigger rules here. As you can see, you have multiple options, and there is also example here provided for you, and you can see that you can pass you can pass a parameter trigger rule non-failed. But in our case here, what it says that here, we are defining this task. We want to say this task should be triggered if any of the upstream tasks, either these two or this task, are triggered. So we want to say one success, any of them that successfully run, we want this task to be triggered. Because one of the things that it took me quite some time to figure out, I defined this like conditional branching to like either go through this path or this path by using the branch Python operator, as you can see here. This branch Python operator, which has an if and else statement, but it was just this task was failing, like it was not being run, it was getting skipped all the time. And I added this option, I had to add this parameter to this task, this trigger rule. So let me change it. So you can either also define it as a like just type it like, let me just you can type it as like one success as a string function. So let me open this. This is that folder here. So as you can see, you can also change this to a string function. For example, you can say and we remove this, and we say one success. This is how you can also define it, one success, which means that either the task they are successful, please trigger this task. This is how you do it, and with comma. Or yeah, so I'm gonna just return it back to the same way that it was. And yes, and now the task dependencies here. So this check file task, this is the task ID. This task ID has been defined by the branch Python operator. This is how you define the conditional and branching tasks. You say either the download iris data should be triggered or the file exist dummy should be triggered. And then, so this becomes two-way. And then you define each of these tasks, the continuation of each of these tasks on the next lines. So for example, we say after this, if this download iris data is triggered, after this downloads iris data, the upload to GCS task should be triggered, and then load to BigQuery should be triggered. And we say if file exist dummy is triggered, this task is triggered, your file exist dummy, and then load to BigQuery. As you can see, this load to BigQuery, this is the common task in these two branches, so which we call it converging task. This is important, and this converging task has this trigger rule parameter. So this was a whole explanation of the task. I hope it was clear. Now let's just run the task now. So this is that Airflow environment, like the web server, the web UI of it provided by the Composer environment for us. As you can see, this is that DAG. You go to this DAG. So right now, we go to this graph view. Right now, as you can see on this Composer demo bucket, there is no data set. So we want this task to go through this path. This path should be triggered. And if we go here and we say run and we wait for it, so let's see what happens. So as you can see here, it's running it. So it says it's on the queue. So the workers, they are trying to run it. Check file exists, this task. Let's see. And this is the colors that says. So this is what is happening right now. You see, the check file exists, the file didn't exist. It's downloaded the iris data, then it's running this upload to GCS, then it also convert the data to BigQuery. As you can see, all the tasks they successfully and then skip this. So this is the feature of this branching, which you can use it in your project quite beautifully and useful. And yes, this is the path. And now if we go to this like we expected, let me refresh here, refresh this bucket, and if you see now the data is downloaded on this bucket, and we also now expect the tables to be here. And if we refresh this environment one time, we go here, we see that the data iris data set is here. Sepal length, sepal width, petal, and species, which is just that categories. And you can also preview the data set of this BigQuery here. All the data are here. So you can use this to store your data quite systematically and in an orchestrated way. And so this is one time. Now if we run this whole DAG one more time, because the data already exists, we expect it to go through this path. So now we run this one more time and we wait for it again. And as you can see, it's running the DAGs here. And we wait for it until it's finished. So because the data existed, it went through this path and branch. And that's the whole this is the whole lab that I wanted to share with you. I hope you find it useful, and you can use maybe a modified and more sophisticated version of this in your project. Good luck.